So trig proofs. Now, when we're talking about a proof, we're trying to make one side basically look like the other side. So if I tell you, I want you to prove that, let me say, x is equal to 2 into x plus 1 minus 2. 2x is equal to that, right?
Mm-hmm.
I'll take one side and I'll try to prove the other. So if I say prove, this happens. Now, you have to take a side. That's the first step, taking a side. But looking at this equation, which side looking easier to take, the left or the right?
You're right in this case.
The right-hand side. So if I take the right-hand side, I could probably simplify it down, correct?
Mm-hmm.
Whereas if I took the left-hand side, it's difficult for me to put the left-hand side in the form 2 into x plus 1 minus 2. It's difficult. But it's easier for me to simplify the right-hand side and prove it equal to the left-hand side. So the first step in our proof is we state that we take in our side. So the proof begins when I say proof, that's where the proof begins. And we take the right-hand side. RHS is right-hand side, LHS is left-hand side. So I take in the right-hand side and I say, well, 2 into x plus 1 minus 2, that's the same thing as 2x plus 2 minus 2, which is 2x, which is equal to the left-hand side, which is what we want. So I took the right and I prove it equal to the left. And this is the basic steps we need to take in proving something. Now, whenever you start a proof, you open the proof with the word proof, but you also need to close off the proof with something as well. There are two ways we can close off a proof. I think the more common one is writing the words QED. So QED is just an abbreviation. QED, it's Latin for proven. It's just knowledge. It means quod erat demonstratum, which means proven in Latin. We approach all trigonometric identities, trigonometric proofs, this same way. I will have something is equal to something, and it's for us to decide which side I want to take. Now, it is recommended, and I will also recommend taking the more, I'll put it in inverted commas, the more complicated side, but not all the time we can decipher which is the more complicated side. In some cases, we'll have to just straight brute force trial and error, take the left, see where we reach. If we stick, all right, I'm gonna fight up. I'll take the right, see where we reach. Now, when you see the proofs, I want you to keep this in mind. Now, sometimes you will get stuck in a proof. You are going to get stuck in a proof and you don't know what to do. My advice, if you are stuck in a proof, take the left, try and make it equal to the right. Do your working. Wherever you get stuck, okay, start with the right and prove it equal to the left. Somewhere in the middle, you are going to get some middle ground where you have this is equal to some line in the first proof is equal to some line in the second proof. And you'll see it actually unfold when we do a proof like it. Once you have the same line in both proofs, it's either you work backward or you work forward to finish the proof. Simple. So we have a couple niche proofs. So let me pull across the proofs here. Basic trig identities, basic trig proofs. Now I am going to try to attempt to do all with you today. We have the solutions here. I'll leave the solutions because there's more than one way to do a proof. It's subjective. Some ways are easier than others, but there are more than one way to do a proof. We'll try to do all of the proofs, right? Right, I'll move these things across over here. Let's get it. So I'll just recall all the base identities. Now, there are 5 accepted identities for CSEC. And we talked about this already. Cosine theta is 1 over cosec. I'm sorry, cosine theta is 1 over sec. Sine theta is 1 over cosec. Tan theta is 1 over cot or sine over cosine. And when we manipulate that, we get cosine theta is 1 over tan, which is cosine over sine. Sine squared theta plus cos squared theta is 1. Those are the identities you are allowed to recall and use at CSEC. 1 plus cot squared theta is equal to cosec squared theta, and tan squared theta plus 1 is equal to sec squared theta are the 2 identities that you're not allowed to quote. If you want to use those identities in a proof, you have to just go through the rigorous proof for it, which is a couple lines. If you see it fit to use those identities, by all means, go ahead and use those identities. So, recall. These are super important. 1, sine theta is equal to 1 over cosec theta. And however we decide to manipulate it, we can. 2, cosine theta is 1 over sec theta. Again, however we want to manipulate it, we can. Tan theta is 1 over cot theta, which is sine theta over cosine theta. And in the same breath, I'll put 4. I'll put cot theta because this one has a little bit of variation in it. Cot theta is equal to 1 over tan theta. But more importantly, it's cosine theta over sine theta. 5 sine squared theta plus cos squared theta is 1. Number 6, 1 plus cot squared theta is equal to cosec squared theta. And number 7, tan squared theta plus 1 is equal to sec squared theta. To use 6 and 7, just divide 5 by sine squared theta, then divide it by cos squared theta in each case. And we did those proofs already, correct? All right. So let me try a thing. Number 1, prove the identity. Sec x minus tan x sin x is equal to 1 over sec x. So I'll write down the proof as we go along, right? So proofs. They can get very, very tedious. We'll try to do all of these we are seeing here. And we will try to probably do all the past papers if we have enough time. Sec x minus tan x sin x. 1. Sec x minus tan x sin x is equal to 1 over sec x. 1 over sec x. Now, when I get a question that says to prove something, write down required to prove. RTP, required to prove, followed by our would proof. Now, in this case, by observation, which one is the quote unquote more complicated side?
The left-hand side.
Left-hand side. So we start the proof by taking the left-hand side. You can say take the left-hand side or taking the left-hand side. We have sec x minus tan x sin x. Now, time to use some identities to simplify this down. The identities you choose, it is subjective. If you want to substitute tan x is equal to something, go ahead. If you want to substitute sin x is equal to something, go ahead. If you want to substitute sec x is equal to something, go ahead. A little guide when you are proving an identity, look at what you're trying to get. I'm trying to get something in terms of sec x. So I'm trying to keep sec x's on the left, or 1 over sec x in the back of my mind, that is cosine x. So I want to see if I could make this fella here look like cosine x, probably. So I'm going to make a couple recollections. So I'll recall, I don't know if I'll use all, but I'll recall what I remember pertaining to the question. If cosine x is 1 over sec, then sec x is 1 over cos. And I can say, tan x is equal to sine x on cos x. And I'll go try a thing. So here I have sec x is 1 over cosine x minus sine x over cosine x multiplied by sine x. This is equal to 1 minus sine squared x over all over cosine x. The denominators are the same, and we are subtracting two fractions, so I can just subtract the numerators. I see another identity unfolding here. So again, I will hit a recall. I'll recall the base identity, sine squared x plus cos squared x is equal to 1, and then rearrange it. Cosine squared x is 1 minus sine squared x. So I'll rewrite my proof. I'll continue my proof by writing cosine squared x all over cosine x. U cancel with u, remaining with cosine x, which is cosine x, which is equal to 1 over sec x. You start the proof, and we finish the proof. It's equal to the right-hand side quad erat demonstrator. Any questions on that? Good to go?
Yeah, with practice. Yep, with practice.
Are these the same? 1 over 1 plus cos over sine, cosec x, cot x. Okay, so it's the same thing here, right? All right, so let me do the second one. Number 2. 1 plus cosine x all over sine x is equal to cosec x plus cot x. All right. Required to prove. Always start your proof with required to prove. Required to prove. All right. Again, which side looks like the more complicated side?
The left hand side.
All right. The left looks like the more complicated side. Now, let me try a thing. Taking the left-hand side yet again. No problem. So, taking the left-hand side, 1 plus cosine x over sine x. Now, there is very, very little which we can recall in terms of identities for sine x and cosine x. There's just one each. I'll recall it. Cosine x is 1 over sec x. And sine x is 1 over cosec x. So I'm going to see what manipulation I can do here. So now I have 1 plus 1 over sec x over 1 over cosec x. Agreed? Yeah? Cool. Now, I showed you the shortcut to add two fractions. If I have a over b plus x over y We multiply a by y first, then multiply b by x, keep the operation in the middle, and we multiply b by y. You notice? Okay, well, there's a shortcut. If I have 1/3 plus 2 over, let me say 7, multiply here by here, multiply here by here, and multiply here by here. 7 and 6 is, this is 13 over 21. All right, super, super helpful, and it is allowed in an exam. It is a legit method of adding two fractions or subtracting two fractions. Regardless if it's algebraic or not, you can use this method. I'm going to attempt to use that for my numerator. All right, so what I like to do, draw a little working column and consider 1 plus 1 over sec x. Well, homeboy, this is 1 over 1. I multiply so, I get sec x. I multiply so, I get plus 1 over sec x. Yeah? So my numerator turns out to be sec x plus 1 all over sec x. And because my denominator is a fraction, only because it's a fraction, I'm not going to put divided by over here. Instead, I'm going to put divided by 1 over cosec x. This way, it's easier for me to see what I have to flip. Much, much easier for me to see what I have to flip. This is equal to sec x plus 1 over sec x multiplied by cosec x. Yeah? But to me, it's not looking like I'm making any kind of progress whatsoever. It's not. Because when I multiply this out, I get sec x cosec x plus cosec x all over sec x. Then you'll argue the fact, well, we can make another substitution or another recollection, but the only recollection I have is what we started with, cosine and sine. So, although it might look like the left is the more complicated side, it looks like it is, but there is little manipulation I can do with it because it's our base identity, sine and cosine. However, the right-hand side is cosec and cot. I have just one thing for cosec, but I have a couple things to substitute for cot. Agreed? I have one on tan, and I have cosine on sine. So let me try a thing. And this is what I mean. I'm taking off this. This is what I mean when I say, if I get stuck, start with the right, make your way, work your way down, and somewhere you'll find the same line. Somewhere you're going to find the same line. If we manage to find the same line, all well and fine. Odds are the working I'm going to do, we're just going to get the proof one time, but I'll show you what I mean inside of that proof. Cosec x plus cot x. So instead, I'm going to work here in the orange, and I'm going to take the right-hand side. I have cosec x plus cot x. I will recall cosec x is 1 over sine x, and cot x is equal to cosine x over sine x. Agreed? Brother man, this fella here is going to be 1 over sine x plus cosine x over sine x. The denominators are the same, so I get 1 plus cosine x all over sine x. Yeah? Now, is equal to the left-hand side, QED. The orange was considerably easier. Now, by doing the proof in orange, it opens my mind to see what I should have done for the proof in black. This fraction here can be split up. it can be split up as this is 1 over sine x plus cosine x over sine x. And this knowledge came because I added these two together. You seeing it? So I didn't have to make no kind of big substitutions to start this proof with. All right. And this is one of the many tricks you will be exposed to. Sometimes you have to be very smart. Sometimes you'll have to, and I'll let you know from now, multiply by 1. And 1 can take an infinite number of forms. 1 could be 2 over 2. 1 is sine over sine, cos over cos, minus sine squared plus 1 over minus sine squared plus 1. All these are valid forms of the number 1. When I multiply by the number 1, I'm not changing the value of anything. I'm just changing how it looks. That's all I'm doing. It's the same seed drink in a different bottle. So let's do number 3. Sec theta sine theta over, I'll just grab this and bring it down so we don't have to keep going back and forth, right? Number 3. Sec theta sine theta over tan theta plus cot theta is sine squared theta. Give me your thoughts on this one. Required to prove, proof. What side are you going to take and why?
Well, from your advice of taking the quote unquote more complicated side, right? I would supposed to naturally gravitate to your left hand side in this case, right?
No
Since-
problem. Left hand side. All right.
Yeah.
So let me try a thing. As per usual, proof. And then required to prove. As you're taking the left hand side, taking the left hand side, good. I'm gonna make my recollections. I'm gonna recall I seen sec theta. I don't know if I'm going to use it, but I'm going to recall it because I've seen it. Sec theta is equal to 1 over cosine theta. Tan theta, I don't know if I'm going to use this, but I'm going to write down the identity for it. Well, there's sine theta over cosine theta, and cot theta is equal to cosine theta over sine theta. My opinion, it's easier once you have your algebraic skills on a lock. It's easy to make as much substitutions as you could. All right. In a case like this, I'm going to have plenty fractions on the numerator and plenty fractions on the denominator. In cases like that, just like I did here, consider the numerator, simplify it. Then consider the denominator, simplify it. So I'm making my substitutions. 1 over cosine theta multiplied by sine theta. Now I'm not trying to write an identity on a line now. I'll use my both lines to write the fraction instead of writing it on one line. It's visually appealing. Over sine theta over cosine theta plus cosine theta over sine theta. Because I have it in this manner, I don't have to consider, if I put the equal sign here, I could show that, I could work out my numerator and then I could work out my denominator easy. My numerator is a multiplication. Brother man, this is sine theta over cosine theta. Then my denominator is an addition. And remember, the shortcut we have, we multiply these two. So those two will be sine and sine. So that is sine squared theta. We multiply these two. That works out to be cosine squared theta. And then we multiply the two denominators. And I get cosine theta, sine theta. Agreed? This is equal to. Now, opposed to on top, if you want, you could have written this with this division sign. You could have if you wanted to. But because it is in this manner, I know I have to flip the big denominator. This homeboy here have to be flipped and multiplied. So I'll end up with sine theta over cosine theta multiplied by cosine theta sine theta over sine squared theta plus cosine squared theta. Good so far? Well, you could cancel with you. Yeah? I get sine theta by sine theta is sine squared theta, which is kind of what I want, over sine squared theta plus cos squared theta. I'll hit them with a recall. This is my base identity. You could have hit this recall up here as well if you wanted, right? Before this line. Sine squared theta plus cos squared theta is equal to 1. So therefore, I end up with sine squared theta, which is equal to the right-hand side quad erat demonstratum. You're following me so far? Let me tackle number 4 now. I could probably delete this now and delete this. Now there are, like I said, there are plenty ways to do these questions, a lot. All right, so number 4, required to prove sec theta over cos theta minus tan theta over cot theta is equal to 1. Which side looking at the more complicated side?
The left-hand side, but
Yeah.
I mean, you could work with the right-hand side too.
You could work with the right-hand side here, but it's difficult for me to expand out one to get it in this particular form.
Right.
Right? But if you wanted, I'll show you how to take the right-hand side and prove it equal to the left-hand side. Followed by the proof. Taking the right-hand side, taking the left-hand side, I have sec theta over cosine theta minus tan theta over cot theta. Again, I see in a couple identities I can recall. I don't know if I'm going to use it, but I'm going to recall it. Recall sec theta is 1 over sine theta, cosine theta, sorry. 1 over cosine theta. Tan theta is 1 over cot theta. And cot theta is 1 over tan theta. And this is sine theta over cos theta. And this is cosine theta over sine theta. Now, usually, like I said before, you look at the other side and see what you're trying to get. In this case, I have 1. 1 takes a couple of forms. Cosine over cosine, sine over sine. So I don't know what I want to work with as yet. I don't know if this identity, when I simplify it, if it's going to work out to be 3 over 3. So I have no particular direction I am looking forward to going. I just go in. Where I reach, I will decide which road I'm going to take. So sec theta is 1 over cosine. So I'll have 1 over cosine divided by cosine theta. Yeah? That is my first term. Agreed? I'm just doing this to make it visually easier for me down the road. Because it's kind of difficult if I have 1 over cosine theta over cosine theta. This could happen. Well, that is 1, and this whole thing is 1. That could happen. It's not equal to 1. So I want to be safe. Minus tan theta. I mean, I could use 1 over cot if I wanted to. Let me try a thing now. Be a little different. 1 over cot theta divided by cot theta. Yeah? Cool. This is 1 over cosine theta multiplied by 1 over cosine theta. Yeah? Which is 1 over cosine squared theta. 1 over cosine squared theta minus, I'll end up with a similar situation here, and I'll get 1 over cot squared theta. 1 over cot squared theta. I can recall something here. I can recall 1, well, I have this one here already. 1 over cos theta is equal to sec theta. So 1 on cos squared is sec squared. And I actually don't have to recall any of them because I'll just manipulate the identities I recalled previously. This fella here is sec squared theta. Agreed? Homeboy here is tan squared theta. Yeah? Now I am going to refrain from using and manipulating this here, because sec squared theta minus tan squared theta is indeed 1. Sec squared theta minus tan squared theta is indeed 1. It is 1. But I'm going to refrain from using it because it's not allowed to recall that identity. Instead, I'm going to try and change this in terms of sines and cosines. And I mean, I could have done it here. I'm going to change this in terms of sines and cosines because that is the identity I am allowed to recall. Cool. So over here now, yes, I made 1 step forward and I'm making a step back, and it's well okay. As you practice and you get better, you will see where you are allowed to make the step forward without making a step back. So sec squared theta is 1 over cosine squared theta minus tan squared theta is sine squared theta over cosine squared theta. The denominators are the same, 1 minus sine squared theta all over cosine squared theta. And I recall sine squared theta plus cosine squared theta is equal to 1. 1 minus sine squared theta. So cosine squared theta is 1 minus sine squared theta. So my identity now turns into cosine squared theta over cosine squared theta, which is equal to 1, which is the right hand side. Quod erat demonstrative. Now, time for the proof. 1 is equal to that. If I take and follow with my here, if I take the right hand side first, my first line is going to be 1 is equal to cosine squared theta over cosine squared theta. Then I'm going to recall cosine squared theta is 1 minus sine squared theta. And I'll only replace the numerator. I'll say 1 minus sine squared theta over cosine squared theta. You following it, man? Then I'll break it up. I'll have 1 over cos squared theta minus sine squared theta over cos squared theta. I'll recall 1 over cos squared is sec squared. And I'll recall sine squared on cos squared is tan squared. Yeah. So all I'm doing is I'm working backwards. That's all I'm doing. I'm just working backwards if I wanted to prove one is equal to that. But it's really unrealistic because how do I know to start with cosine squared theta over cosine squared theta? Just as easy, I could have started with sine squared theta over sine squared theta. Right? I could have started with 6.5 or 6.5, but we are going with it. All right, let's do we on number 5. All right, so we enter in some bigger territory now. Required to prove. Required to prove cosine squared y minus sine squared y is 1 minus 2 sine squared y. Which side you want to pick, left or right? Which side looks more complicated, left or right?
Left. Yeah, left.
Yeah, which side?
The left hand side.
Left hand side, right? Why not the right hand side?
Because I could probably translate one to sine squared theta plus cosine squared theta and make something happen there.
We could do the same thing on the right.
Let's just look. I mean, well, that'll be equal to 1. Oh, actually, shucks. No, my bad.
This the left hand is equal to 1.
No, sorry.
Oh,
Thought I see a plus sign there.
now in a case like this, I will say both sides are equally as complicated, so you can take either side. I can make substitutions on either side.
Yeah.
All right. Just like in the first one, I could have take the left. Yeah, I could have take the left, make it equal to the right. No, the second one. I could have take the left, make it equal to the right by looking at the green. Yeah. Now I have the knowledge of doing that. Or I could have take the right and make it look like the left. Yeah. All right. So let me check out this one here. So I'll take the left-hand side. I'll have cosine squared y minus sine squared y. Now I'm going to recall whenever I have the angle in the proof that the angle using in recollection. We're not using theta, we're not using x, we're using y. Sine squared y plus cos squared y is equal to 1. What are you going to make the subject of the formula?
We could make either sine or cosine squared.
Which one you want to make the subject of the formula?
Sine squared. Yeah, sine squared y.
So think about it, right? Look at what I'm trying to get.
Oh, sorry. No, cos. Yeah, I want everything in terms of sines.
Very good.
I would really have to get a cos. Yeah, I'd have to make cosine the subject of the formula in this case.
Very good. Right? Because I'm trying to get a sine here, I want to get rid of the cosines. So I'll say cosine squared y is 1 minus sine squared y. So I have 1 minus sine squared y. Take away sine squared y, which is equal to 1 minus sine squared y minus sine squared y, which is 1 minus 2 sine squared y, which is the right-hand side. Yeah. Now, I just want to show you a little versatility. Above, if I wanted to take the right and prove the left, I say we could work backwards. If I want to take the right and make it equal to the left, I can work backwards. I'll split up this as minus sine squared y minus sine squared y. Then I'll group this and say, well, this is cosine squared y, and I get my proof. But that is not the only way to do it. If I take the right-hand side, 1 minus 2 sine squared y. I can make a substitution for sine squared y here. I can recall sine squared y plus cos squared y is equal to 1. So therefore, sine squared y is 1 minus cos squared y. Agreed? Now I want you to pay attention and help me here, right? 1 minus 2 sine squared y is 1 minus cos squared y. I end up with cosine alone. How am I going to incorporate a sine inside of here now?
We could say that 1 is equal to cosine squared y plus sine squared y.
Very good. I'll make a substitution for this one here. It don't matter which one you make it for. This one by himself. So I'll make the substitution for that one. So instead of having that, I'll have 1, which is sine squared y plus cosine squared y minus 2 sine squared y, which is 1 minus cosine squared y. Sine squared y plus cosine squared y minus 2 plus 2 cosine squared y. Yeah? Sine squared y plus 3 cosine squared y minus 2. Indeed. I think it's just a little harder to prove this way. You can see it harder to prove this way. Yeah. Just food for thought. It will be harder to prove this way because I'm not taking this approach to work backwards. Because again, I don't know in the back of my brain if it is the right thing to split up the sine squared y. I don't know. Right? It's a far stretch to know what to do when you have a question like this and I want to work from one way to the next. This is a valid way of doing it. It can be proven. I'll have to make back another substitution for probably cosine squared y. And keep making some substitutions, but I'm gonna waste my time. All right? I'm gonna waste my time. That was number 5. All right, so I'm gonna pay to do number 6 and number 7 and 8, and we go do the solutions when you finish. The error you make is a very common error, and I think we will use this as a learning experience, right? All right, so number 6, required to prove. Now CSC is cosec, all right? I'm gonna write it out. Cosec squared theta tan squared theta minus 1 is tan squared theta, followed by the proof. You see you're taking the left, right? You recall, now it's always good to recall the base identity first. Cosec theta is 1 over sine theta. Yeah? From this stems cosec squared theta is 1 over sine squared theta. Tan squared theta or tan theta is equal to sine theta over cosine theta. And from this stems tan squared theta is sine squared theta over cosine squared theta. And you also said that sine squared theta plus cos squared theta is 1. Sine squared theta plus cos squared theta is 1. So you would have had 1 over sine squared theta multiplied by sine squared theta over cosine squared theta minus sine squared theta plus cos squared theta. Yeah? You see this could cancel with this. And I get 1 over cosine squared theta minus sine squared theta plus cosine squared theta all over 1. You attempted to do this, correct? You would have gotten 1 minus cosine theta into cosine squared theta into sine squared theta plus cosine squared theta all over cosine squared theta. But here I'll end up with a cosine to the power 4 theta, which is kind of bacchanalish. So instead, just because you see a substitution to make, don't mean you necessarily have to make it. So instead, I'm not going to touch this minus 1. I'm going to have one over sine squared theta, continuing from this line here, 1 over sine squared theta multiplied by sine squared theta over cosine squared theta minus 1. Bam, bam. 1 over cosine squared theta minus 1. Yeah? Now, we can do a couple of things here. I can go old-fashioned, so. And I get 1 minus cosine squared theta all over cosine squared theta. Yeah? This is sine squared theta. Agreed? I get sine squared theta over cos squared theta. Or I want to introduce a little concept here. This is minus 1. As we stated before, 1 takes an infinite number of forms. With the practice, you all will realize which form 1 should be in for a particular identity. In this case, I'm going to put 1 as cosine squared theta over cosine squared theta. All right? It might seem easy, like, yeah, I cannot do that. But there will be cases where it's not that clear cut. So this is the same thing as 1 over cos squared theta minus 1. The denominators are the same. So minus my numerators. And now I recall that I have the base identity recalled already in the first place. So cos squared theta, 1 minus cos squared theta is sine squared theta. So I end up with sine squared theta over cos squared theta, which is tan squared theta, which is equal to the right-hand side, QED. So you might have seen me draw a little box here. This box is also a symbol for proven. All right, but we use QED. All right, so go ahead, try number 7, and we'll do the solutions when I finish. Right, so take the left-hand side, recall. Before you hit that recall, when you take the left-hand side, write down the left-hand side. Actually, write it down. Okay. Then recall. So we have sec squared theta. And again, recall your base identity. then make your alterations to your base identity. So first you'll recall sec theta is 1 on cos, then sec squared theta is 1 on cos squared theta. So you'll have sec squared theta, which is 1 on cos squared theta, divided by 1 over cos squared theta minus 1. So you get 1 over cos squared theta multiplied by cos squared theta over 1. So mistakes were made here. I am not dividing by 1 over cos squared theta. I am dividing by 1 over cos squared theta minus 1. So you see in this line here, in this line here over here, you divided by 1 over cos squared theta, which turns into a multiplication of cos squared theta. So whenever you have division of something and it has more than one term in the denominator, do this.
Okay.
All right. That will put it into perspective. So let me do the solution, right? So this alone here will cause you to not get the answer. So I'll say, well, required to prove followed by proof. Taking the left-hand side, sec squared theta over sec squared theta minus 1. I'll recall, just like you did, that sec theta is equal to 1 over cosine theta. And as a result, sec squared theta is 1 over cosine squared theta. So I'll have 1 over cosine squared theta divided by 1 over cosine squared theta minus 1. I'll fix this in the bracket here. I'll use my shortcut. There's over 1 and multiply so and so. Cool?
Yep.
So this is 1 over cosine squared theta. It's still divided because I am doing nothing with the, I am flipping nothing as yet. I just simplify in the brackets. I'll get 1 minus cosine squared theta all over cosine squared theta, which is 1 over cosine squared theta multiplied by cosine squared theta over 1 minus cosine squared theta. Bam, bam. And I get 1 over 1 minus cosine squared theta. Now, we're in a little bit of problems here because I'm trying to get cosec squared theta. Yeah? So I'll recall my next identity. 1, sorry, sine squared theta plus cos squared theta is 1. And sine squared theta is 1 minus cos squared theta. So the identity works out to be 1 over sine squared theta. And I'll come back up in the recall, and I'll recall that 1 over sine theta is cosec theta. So 1 over sine squared theta is cosec squared theta, which is equal to the right-hand side. Quad errant demonstrate. Yeah? Yep. Cool. All right, so final one, number 8. Give it a try. We'll do the solutions when you are finished. All right, so let's do the proof here. Tan squared x sine x is equal to tan squared x minus sine x. So you try it and encounter some issues. So let me see what we can do. More complicated side. Let's say.
Both of them complicated, so I just choose the left-hand side at the start.
No, so choose the left-hand side. At any point in time when you encounter difficulties, did you try to choose the right-hand side?
Yeah.
And
yeah.
did you encounter the same set of difficulties?
No, a different set of difficulties.
At any point in time with your left-hand side working is equal to the right, and your right-hand side working is equal to the left. At any point in those two working, do you have the same line?
Well, I can rub off the left hand side and then start over the right hand side.
No, that's counterproductive because, like I said, in the orange working, taking the right-hand side showed me how to prove it using the left-hand side. So let's just say I took the right-hand side and I had, let me just say, hypothetically, I had more working than this. But in the right-hand side working, I had a line from the left-hand side working. Follow me?
Yeah.
If I have the same line in both sets of approaches, I already proved the proof because I did working to get to this line. Yeah. And I did working to get to this line. Following with me. My end result down here supposed to be the right-hand side, and my end result down here is supposed to be the left-hand side. Correct? Yeah. So if I reach here and I reach here and I have the same line, I can completely prove by putting everything previous to be next. You understand? Yeah. So let me see what we can do down here. That is very important, not to rub off things, especially in proofs. So you'll see something will unveil itself. So as usual, I'll omit some statements required to prove, followed by proof, taking the left-hand side. Tan squared x, sine squared x. Now I will recall that tan squared x, well, tan x is sine x on cos x. So recall tan x is sine x over cosine x. So tan squared x is sine squared x over cosine squared x. So I end up with sine squared x over cosine squared x multiplied by sine squared x. What am I going to do here? You know much. Yeah. If I want, I could say make a substitution for sine squared x. Yeah. And I get sine squared x is equal to 1 minus cosine squared x. Fair enough? Let me try that. Recall sine squared x plus cos squared x is equal to 1. So sine squared x is 1 minus cosine squared x. I'm using the sine squared x alone. Cool. Sine squared x over cosine squared x multiplied by 1 minus cosine squared x. Expand the bracket. I get sine squared x over cosine squared x minus sine squared x over cosine squared x multiplied by cosine squared x. You cancel with you. Already have the identity above. This is tan squared x minus sine squared x. It's the right hand side. Q E D. Doctor.
Yeah.
Where did you go astray?
I did not. Okay, so the last statement for the, well, I do this on the right hand side now. So my last statement was sine squared x on cosine squared x minus 1 on 1 minus cosine squared x on 1.
All right.
Yeah, I just stick it because it I guess I doubt myself. So I was
Try
like,
something. Always try something. See what happens. The most important, one of the most one of I wouldn't say most important. I'm unimportant thing to do is do not rush. If you don't know how you get a line, something is wrong. Something is definitely wrong, because if you don't know how you get a line, you could have made a mistake to get that line, to reach there. So try your best not to, how I get this, rush, right? Never rush.
no, I wasn't rushing. I just like it.
No, I never say a rush. I just telling you for future. Do have a
Yeah.
rush in the
Yeah,
event
yeah.
that you're struggling. Don't
Mhm.
manifest something that isn't there.
Yeah.
All right. So I want to do some. Well, I want to do one in particular, and I will leave the rest for the next class. So it's not the 20. It's supposed to be the 2011 one I'm interested in. It is the 2011 question. This question comes from specimen paper 2, 2011, paper 2, number 4, part C. So I'll leave you to try a thing. You calling me? No, I recording. You calling me for?
I know. I'm trying to like not mess up the recording.
No, just tell me something. Tell me what you tell me.
Let's give me like you give me about 3 minutes.
Yeah. Cosine theta squared is equal to minus sine theta minus 1 over sine theta plus 1. All right. So for those online, I want you all to go in the past papers. I will be doing the solutions for all of the past paper questions in the future. Probably soon. I'll have these recordings up. So do them and you'll see the solutions for all of the trigonometric proofs from 2011 all the way up to 2021. What was your first step?
So recall tan theta is equal to sine theta and cosine theta. All right, so I kind of work any brackets first. So it'll be sine theta and cosine theta minus 1 and cosine theta, same denominator, so put them together, right? So sine theta minus 1 and cosine theta all squared. Now, when I go, that's technically, I use lots of indices for this, right? Kind of. So when sine squared theta minus 1 and cosine squared theta minus 1. Sorry, just cosine squared theta alone. Now, I kind of watching everything had to be in terms of sine on the right hand side, right?
Yeah.
So I wanna try and get everything in sine. And well, a little trick from quadratics is the difference of two squares. So right. So I try that, right? I try. So I obviously I recall my sine squared theta plus cosine squared theta is equal to 1, and then I make cosine squared theta the subject of the formula to get 1 minus sine squared theta. And I substitute that in, and then I break everything up into difference of two squares, and then I came up with these right up, right? Sine theta plus 1 multiplied by sine theta minus 1, all on 1 plus sine theta, open and multiply by 1 minus sine theta. That's what I have so far.
All right, good. Very good job. Excellent job. So the first
Classic.
thing you did was take the left.
Yes.
You brought the brackets as one fraction inside.
Yeah.
Yeah. Well, you substituted tan theta. So I'm not going to recall anything because we know we're supposed to do it already.
Yeah.
So this turns out to be sine theta over cosine theta minus 1 over cosine theta all squared.
Yeah.
Simplify that. I get sine theta minus 1 over cosine theta all squared. By the laws of indices, this is a quotient. The top have to be squared, the bottom have to be squared. So this now is equal to sine theta minus 1 all squared over cosine squared theta. Yeah?
Yeah.
The top is sine theta minus 1 into sine theta minus 1. Right?
Plus is not plus.
This is not a difference of two squares. A difference of two squares takes the form a squared minus b squared,
Whoosh,
not
right.
a minus b all squared. So this is sine theta minus 1 multiplied by sine theta minus 1. Now, if I go back up, again, I'm not going to write down the recollection, but you have to write it down. Cosine squared theta is the same as cosine squared theta will be 1 minus sine squared theta. Agreed? So my denominator becomes 1 minus sine squared theta. The denominator is now a difference of two squares because the denominator can be written as 1 squared minus sine theta all squared. So the numerator is sine theta minus 1 into sine theta minus 1 all over 1 squared minus sine theta all squared. This and this is the exact same thing, just written differently.
Yeah.
And this is one of the tricks, another one of the tricks in proving identities, noticing a difference of two squares. A difference of two squares will occur from our base identity, sine squared theta plus cos squared theta is equal to 1. Whenever I rearrange it, I will always get a difference of two squares. It'll be 1 squared minus sine squared or 1 squared minus cosine squared. Since the bottom is a difference of two squares, I had to say that. Brother man, you could put an arrow if you want and say this is a difference of two squares. So this is equal to sine theta minus 1 into sine theta minus 1 all over 1 minus sine theta into 1 plus sine theta. But the problem here is nothing could cancel. Absolutely nothing on the top is equal to something on the denominator. So
Right.
nothing could cancel. Going back to one of the skills we learned by multiplying by the number 1. 1 takes an infinite number of forms, correct?
Yeah.
And again, with the practice and the experience, you have to practice, otherwise you can't get it with just doing 2 examples. You have to practice it because it occurs quite often to know what form to multiply by. In this case, I must multiply by minus 1 over minus 1. And minus 1 over minus 1 is 1.
Yeah. Mm-hmm.
So I'll multiply by 1 in that special form. So if I multiply by minus 1 over minus 1, I'm going to distribute the minus 1 on one of the brackets. It's multiplication. I'm not multiplying this minus 1 by both brackets. I'm multiplying it by one of the brackets alone.
Yeah.
And I'm going to leave this minus 1 on the denominator. All right, I'm not distributing that minus 1 on anything on the denominator. So I'll distribute the minus 1 on the top on the first bracket. So when I distribute that, the sine theta becomes negative and the 1 becomes positive. So I get 1 plus sine theta. Agreed?
Mm-hmm.
Sorry, 1 minus sine theta, my bad. 1 minus sine theta. I already used the minus 1 on the top. Sine theta minus 1 all over. I'm not going to touch this minus 1 on the denominator. 1 minus sine theta, 1 plus sine theta. Now I have something in common. 1 minus sine theta and 1 minus sine theta. This is sine theta minus 1 over minus 1 plus sine theta. In a fraction, matters not where the negative sign goes. It could go on top, it could go below, or it could go in front of the entire fraction. For example, 2 over minus 3 is the exact same thing as minus 2 over 3, and is the exact same thing as minus 2 over 3. So I will put this minus sign in front of the whole fraction, and I'll get minus, and I'll change it up to suit. Sine theta minus 1 over sine theta plus 1, which is equal to the right-hand side. Quadrant demonstrable. Yeah.
Kind of lost on how it was 1 minus sine theta from sine theta minus 1, and when you multiply by negative 1, you
All
went
right.
to 1 minus sine.
So sine theta minus 1, I'm multiplying the minus 1 there, right?
Mhm.
So I'll get minus sine theta plus 1.
Oh,
Right?
okay, yeah.
Which is the same thing as 1 minus sine theta.
Okay.
Yeah?
Yeah.
Now, if I wanted, I could have distributed the minus 1 on one of the denominators, right? And I'll distribute it on the first denominator. You have to pick and choose, right? You can't distribute it on any one. If I distributed it on this denominator, the sine theta becomes positive, and the minus 1 becomes negative. Then you will cancel with one of the numerators, and I'll end up with the same answer in the end. Exact same answer. So this is your job. Go through your past papers. This is 2011. We have 2012, 13, 14, 15, 16, 17, 18, 19, 20, 21. We have 10 years worth of past paper questions for this. Go through them, do all, and we'll do the solutions.